Chapter 5, Lesson 4, The Distributive Property. Real World Link, School Supplies. Jordan buys 3 notebooks that cost $5 each. He also buys 3 packages of pens for $6 each. Write an expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens. Well, we know that each notebook costs $5. And I know that from notebooks cost $5 each. Then he also buys 3 packages of pens, and packages of pens are $6 each. So we're doing 3 times 5 plus 3 times 6. So write an expression that shows 3 times the cost of 1 notebook and 1 package of pens. So 1 notebook is going to cost $5. 1 package of pens is going to cost $6. That's each. Now we're doing 3 times that. So we're going to evaluate both expressions. Well, for number 1, 3 times 5 is 15, plus 3 times 6 is 18. 15 plus 18, well, if you want, you can always show your work off to the side. 8 plus 5 is 13, carry the 1, 33. So this is going to cost $33 for 3 notebooks and 3 packages of pens. Now for number 2, we're going to do the parentheses first. 5 plus 6 is 11. So 3 times 11 equals $33. So if we take 3 times the cost of 1 notebook and 1 package of pens, it's going to cost $33. So for number 3, we evaluate both expressions and it says, what do you notice? Well, the expressions have the same value. So number 4, suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. We're going to circle the expressions that represents Jordan's purchases. Well, we have 5 notebooks that cost $3 each. Well, that means that we're going to have 5 times 3. And then 5 packages of pens that cost $1 each. That's going to be 5 times 1. So 5 times 3, and we're going to add those together. Ooh, here, that first one works. Well, the middle one doesn't because that's multiplying all of them, and that's not true. But the last one also works because it's 5 of each notebook and 5 of each pen. So number 5, suppose Jordan buys 2 rulers that cost $1 each. So that's going to be 2 times 1 plus 2 folders that cost $1.50 each. So 2 times $1.50. Well, it's not going to be the first one because that's all addition. We need multiplication in there as well. But the second one and the third one both work. So use the distributive property. We're on the next page. The distributive property states that to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside the parentheses. So if we have the symbols that are on here, we have A times the quantity B plus C. That means that we take A and multiply it by B, which becomes AB, plus A times the quantity of C, which becomes AC. So that's if you have addition. Now, if you have subtraction, A times the quantity B minus C, you distribute the A times the B, which is AB, and then A times the C, which is AC, and you subtract those values. So you can model the distributive property with algebraic expressions using algebra tiles. The expression 2 times quantity x plus 2 is modeled below. First, we take our algebra tiles and make x plus 2. So the green tile is our variable x. The yellow tiles that are labeled with 1s are representing our number 2. Then the second step is to double the amount to represent 2 times the quantity x plus 2. If you notice from the second box to the third box, they've rearranged the x's and the 1s. This is so then it makes it easier to see that it is actually 2x plus 4 after you've distributed. So the expression 2 times quantity x plus 2 and 2x plus 4 are equivalent expressions. So no matter what x is, these expressions have the same value. So equivalent means equal to. So these expressions are equal to each other. So let's try example 1. Use the distributive property to evaluate 8 times the quantity negative 9 plus 4. So we're going to take 8 times negative 9, and then we'll do 8 times 4. So 8 times negative 9 is negative 72, plus 8 times 4 is a positive 32. So when you add those together, negative 72 plus 32, that gives you negative 40 as your answer. So let's try letter A, B, and C. So we have 5 times the quantity negative 9 plus 11. I'm going to take 5 times negative 9, which is negative 45, plus 5 times 11, which is 55. I'm going to combine those. Negative 45 plus 55 gives me an answer of 10. And if you want, you can write equals in front of all of these. So letter A is 10. Letter B, 7 times the quantity, 10 minus 5. Well, 7 times 10, actually, before I even do that, there's subtraction, so I'm going to change that into adding a negative 5. So 7 times 10 becomes 70. 7 times negative 5, I'm going to add a negative 35. 70 plus negative 35 equals 35. So letter B is 35. Cool. Letter C, we are going to take the quantity 12 minus 8 times 9. Now this one looks different because our 9 is in the back instead of in front of our parentheses. It doesn't matter. It's the commutative property of multiplication, so you can multiply in any order and it's still going to give you the same answer. It just looks a little different. So before I distribute, I'm going to change this subtraction to adding a negative 8. If it helps, you can write 12 plus negative 8 times the quantity 9. I'm sorry, the quantity 12 plus negative 8 times 9. So I'm going to take 9 and I'm going to multiply it by 12. Well, that one I don't necessarily know off the top of my head, so I'm going to show my work off to the side. Again, I don't want to use a calculator because I can't use calculators in this unit. So 9 times 12 is 108. Then 9 times negative 8 gives you a negative 72. So when I take 108 and I subtract 72 from that, let's see, that's going to give me a 6 and a 3. That gives me the answer of a 36. So as you can see, sometimes I need to show my work off to the sides, and there's absolutely nothing wrong with that. That is absolutely allowable. Continuing to the next page. No, please bear with me for a moment. It was not loading. There we go. Example 2. Use the distributive property to rewrite each expression. So we're going to take 4 times the quantity x plus 7. So this is a little different than the previous problems that we were doing because there's a variable this time. Nothing wrong with that. Now we're just going to have a letter in with our numbers. So we're going to have 4 times the 4 times x, and then 4 times 7. So 4 times x plus 4 times 7. Well, 4 times x becomes 4x, plus 4 times 7 is 28. Now we can't combine 4x and 28 because one has a variable and the other one doesn't. You can't put a car in the same category as a pineapple. They're not the same. Even if the color's the same, again, not the same. So that was number 2. Let's try number 3. We have 6 times the quantity p minus 5. Well, it's subtraction, so I'm going to add and make it into a negative 5. 6 times p, and then I'm going to do 6 times negative 5. 6 times p plus 6 times negative 5. That simplifies to 6p plus negative 30. Again, I can't put 6p together with negative 30 because they are not the same, meaning one is a constant, which is negative 30, and the other one has a variable, which is the letter p. If you look, our last step is to simplify plus negative. Well, we can't ever write it as plus negative. We need to write that as a subtraction because a positive times a negative is a negative. So this is a definition of subtraction. This becomes 6p minus 30. All right, let's work on step number 4. Negative 2 times quantity x minus 8. All right, well, I'm sorry. There's subtraction, so I'm going to add and make that into a negative 8. And I'm going to distribute a negative 2 to x and a negative 2 to negative 8. Negative 2 times quantity x plus negative 2 times quantity negative 8. Negative 2 times x is a negative 2x plus negative 2 times negative 8. Well, negative times a negative is a positive. 2 times 8 is 16. Well, I can't simplify that any further because I have a variable term and a constant term. So that's my answer. Number 5. 5 times the quantity negative 3x plus 7y. I'm going to take my 5 and I'm going to distribute it to my negative 3x and to my 7y. So 5 times negative 3x plus 5 times 7y. 5 times negative 3x is a negative 15x. Plus 5 times 7y is a 35y. Well, I can't combine my terms anymore because my x and my y are not the same variable. They're not both x's and they're not both y's. So therefore, I cannot combine them any further. So that's my answer for number 5. Looking at number 6 now. 1/3 times the quantity x minus 6. Well, I'm going to change this subtraction into adding and making it into a negative 6. And then I'm going to distribute. Oh, goodness gracious. I'm going to distribute this negative 3 to x and this negative 3 to negative 6. I'm sorry. I'm going to distribute this 1/3 to x and this 1/3 to negative 6. So that becomes 1/3 x. It's 1/3 times quantity x plus 1/3 times quantity negative 6. Well, 1/3 times x becomes 1/3 x plus 1/3 of 6 is going to be a 2. Positive times a negative is a negative. My last step is to simplify this plus negative into subtraction. So that's 1/3 x minus 2. So we're going to try D, E, F, and G. So for letter D, I'm going to show that work to the left. 6 times the quantity A plus 4. I'm going to distribute the 6 to A and to the 4. So 6 times A plus 6 times 4. This becomes 6A plus 24. I can't combine a variable term and a constant, so that is it. That's my answer. All right, letter E, I'm going to do up to the left as well. The quantity m plus 3n all multiplied by 8. Well, I know that this looks different, but as we did before, I'm going to distribute this 8 to the m and this 8 to the 3m. Just because it's written on the back doesn't mean that it's going to change how we're solving this. So that becomes 8 times m plus 8 times 3n. 8 times m becomes 8m plus 8 times 3 is 24, so that becomes 24n. Different variables, can't combine them, so that's it. Letter F. -3 times quantity y minus 10. Well, instead of saying y minus 10, I'm going to say plus -10. Then I'm going to distribute this -3 to y and -3 to -10. -3 times y plus -3 times -10. -3y plus 3 times 10 is 30. Negative times a negative is a positive. So -3y plus 30. Letter G. We have 1/2 times quantity w minus 4. So I'm going to change this subtraction to adding a -4. Then I'm going to distribute my 1/2 to w and to -4. So 1/2 w plus 1/2 times -4. 1/2 times w becomes 1/2 w plus half of 4 is 2. Positive times a negative is a negative. So we have to simplify this. We can't leave it as plus negative. So that becomes 1/2 w minus 2. Let's move on to example 7. Mr. Ito needs to buy batting helmets for the baseball team. The helmets he plans to buy are $19.95 each. Find the total cost if Mr. Ito needs to buy 9 batting helmets for the team. Okay, well, there are multiple ways that you could do this. If you're thinking 9 times 19.95, you could absolutely do it that way. So showing my work off to the side, 19.95 times 9. 9 times 5 is 45, carry the 4. 81 plus 4 is 85. 81 plus 8 is 90. There's 9, and that's 18. 2 numbers to the right. So you should be having $170.55. I'm sorry, $180.75. Oops, I did a boo-boo. I apologize. It should be $179.55. Okay, another way that the book has shown this is estimating. 1995 is very close to 20. So we'll say that it is $20. And then if we take away 5 cents, that gives us the 1995. So we're going to do 9 times 20 minus 9 times 500. 9 times 20 is 180. 9 times 500, well, that's going to be 45 hundredths. So when you subtract these two, that's going to give you $179.55. Same answer as I got when I did multiplication without estimation. Again, either way is appropriate. So letter H, a sports club rents dirt bikes for $37.50 each. Find the total cost for the club to rent 20 bikes. Justify your answer by using the distributive property. So you can take 20 times $37.50. So I'm going to distribute 20 to 37.50. So this is going to cost you $750 if you rent 20 bikes.